major problems identified by our team. The first one is existing hydropower plants needs huge land and resources. As we all know that to construct a traditional hydropower system, it requires dams, reservoirs and large infrastructure, which demands a lot of space, money and environmental clearance. The second problem is pipeline water flow is never utilized for energy generation. We have continuous water flow in building pipelines, but this potential energy is normally wasted and not used to produce electricity. And the third problem is power demand is increasing in recent days. With growing population and urbanization, the need for electricity is rising, creating a pressure on existing power sources. This project focuses on generating electricity from the water distribution systems in multi-story buildings such as college, hostels, apartments and malls. These buildings typically use rooftop water tanks that supply water at around 40 liters per second through parallel pipes. We identified the untapped potential of the gravitational energy in this flowing water and developed a compact micro hydro generator to convert it into electricity. To make the system smart and efficient, we integrated IoT for real-time monitoring and machine learning for performance optimization and predictive maintenance. The design is cost-effective and easy to implement and offers high efficiency, making it a sustainable solution for urban energy needs. There are two main business potential. The first one is corporate CSR and sustainability goals. The second one is growing support from government and smart city missions. And so our target consumers are smart cities and municipal corporations, commercial buildings and tech parks, metro rail and urban transport authorities, industrial zones and sewage treatment plants and water treatment facilities. Here the tub represents the water tank above the multi-story building, and the water flowing through the flow rate sensor falls onto the turbine. As the turbine rotates, electricity is generated and its speeds depend on the amount and pressure of the water. A dynamo generator is used to convert this rotation into power, and the grey device behind the turbine is the dynamo generator. The ESP32 controls all the sensors, and the sealed lead acid battery stores the generated energy. The flow rate sensor measures how much water passes through it, and its value is displayed on a OLED display, while the Arduino Uno R3 acts as the main controller. So this is the sealed lead acid battery, and as you can see, the turbine rotates when the water falls on it and generates electricity. And this is the flow rate sensor, and its readings are shown in the OLED display. So when the water level is decreased and the pressure is dropped, the flow stops. When the flow stops, the turbine stops rotating. When the turbine stops rotating, no power will be generated.